Hi, my scholars. I hope everybody's doing well. Let me share my screen with you. And please bear with me tonight because I'm going to be back and forth in between PowerPoint and Excel because I want to touch on bases in different places. What do you call a man that spent all summer at the beach? A tangent. My name is Jessica Johnson. I'm in Math for Teachers 2. And I want to talk about algebraic reasoning, graphing, and connections with geometry. We are asked to graph a chart of gas in a gas tank when a driver refills the tank while they're driving across country. So here we are. We're driving across country, and on the x-axis, the distance is the distance we travel. And the farther we travel, the gas tank goes down. Then we're going to stop and we're going to refill. And this is actually going to go straight up because we're not actually traveling a distance. And the y-axis denotes our gas tank going up. And then we're going to start traveling again. The farther we go along the distance, the y-axis is going to decrease, denoting our gas tank. Then we're asked to graph an elevator going up to each floor. Here we are on the bottom floor on the y-axis. We go up to the height to the next floor. We're going to go along the x-axis, which is the length of the time the elevator has stopped. And then we'll go up to the next floor. And if you'll notice, the elevator stopped longer here and shorter here. It depends on how much the elevator is being used. Depends on how short or long the x-axis will be, but the y-axis should be pretty consistent to the next floor to the next floor. Now let's graph a ball falling off of a table. Here's the top of our table. We drop the ball drops down to the floor, it bounces up into an arch and comes back down and hits the floor along the x-axis. The y-axis shows the ball coming back up, arches, and the arch is going to get shorter and the width is going to decrease as well with each bounce, and then eventually it's just going to come and roll. Now let's graph the shadow of a flagpole as the day changes from sun up to sundown. At the start of the day, the shadow is going to be taller. As the day goes by, the shadow is going to get shorter, and then it's going to get taller again. Question 2 asks us to look at functions. And I like to think of function as a machine where you're going to input X and you're going to output Y. And the machine has to follow certain rules. So I stayed up all night and I built some input-output robots. And I was asked to input 0. My robot had to follow the rule of multiply by 3 and add 8. And we got an output of 8. We input 1, follow the rule, we got an output of 11. Input 2, follow the rule, output of 14. Input 3, we get an output of 17. Now I want you to stop and just notice for a second that 8, 11, 14, and 17 all increase by 3. There's going to be more to this story in just a few minutes. Here, I want to show you how to graph a function by hand and plug in the inputs into our function. We were asked to multiply by 3 and then add by 8. And then we got 8. Let's get rid of that and let's go to Excel for just a moment. Here I put in the values 0, 1, 2, and 3 for the X value. And then my X value has to obey the rules or the functions of f of x equals 3x and g of f of x equals f of x plus 8. And you see we learned earlier that we increase by 3. Also this column right here increased by 3, 3, 6, 9. Now then take 3 and add 8 and you get 11. Take 6 and add 8 and you get 14. Take 9 and add 8 and you get 17. This is the rest of the story that I was telling you about. You can see that our graph followed the rules. They had to multiply by 3 and then add by 8. And when let's just pick a plot on the graph here. Let's say f of x equals 3x and x is 2. Then we can see when it's 2, it's going to increase by 8, and g of f of x equals f of x plus 8 is going to be on 14. I love it. It's great. Question 3, we're given 2 plots, and we're going to plot these on a graph and then describe the line, whether it's vertical, horizontal, sloping upward and to the right, and then we're going to give the slope. So we have the values for x is 3 and y is 1, and x is 5 and y is 5. And these are plotted on the graph over here, and we can see that our line is going up and to the right. And now I'm going to show you how to figure the slope. This is one way you can figure the slope. You can take these squares and count them 1, 2, 3, and 4, and this is on your y-axis, and the y-axis is called your rise. And then you count the x-axis, 1, 2. This is called your run. So what we really have here is delta y over delta x. So we have the change in y is 4, and the change in x is 2. 4 over 2 is 2, and slope is 2. M represents our slope. Here we are given 2 points of 5 and 8, and 5 and -8. And I graphed it on did the plots on the graph right over here, and we can see that we have a vertical line going straight up and down. And now I'm going to show you the slope. Slope equals y2 minus y1 over x2 minus x1. I like to label my points, my plot points. That way I don't mess up. And then I can just plug my values into my formula right here, and we have slope of -16 over 0. And when we have a 0 in the denominator, it is undefined. Then we are given another 2 points. We are given -1 for x and -4 for y, and -4 for x and -13 for y. Here our line is going downward and to the left, and we know this because of the negative on the x and the y axes. And let's figure the slope. Here's our formula, m equals y2 minus y1 over x2 minus x1. Here are our given plots. I like to label them. I fill in my formula, and we have a slope of 3. Question 4 asks us to explore parabolas. I use the values for x of -2 all the way to number 2. And you could have used any range for this, and you would have came up with different parabolas. But the point is that x has to follow the functions of y equals x squared, and y equals x squared plus 7, and y equals x squared minus 7. It has to follow these rules. And then when we graph these parabolas, we can see that they all have the same bell curved shape, but they're on different spots on the graph. We have y equals x squared plus 7, that's in the positive, y equals x squared right in the middle, and y equals x squared minus 7 in the negatives. So when y equals x squared plus 7 is 0, 7, then y x squared is going to be 0, 0. And then when y equals x squared minus 7, it's going to be 0, -7. And we can compare our information with the chart on the left to the graph on the right. Question number 5. Here we are asked to show and explain an equation of the line through a given point that is perpendicular to a given line. I used the range of -12 to 12 because I wanted to explore with different values. And I'm going to apologize for my chart because it's a little distorted whenever I snipped it from Excel to PowerPoint, but I'm going to take you to Excel and show you what my graph really looks like. And we were given the point of R of 6, -1. And our formula is y equals -3/4 x plus 5. And the 6 is on the x-axis and -1 is on the y-axis. To figure the slope, we need to use the point slope formula, which is y minus y1 equals m times x minus x1. Y1 is your y-intercept on the graph, m is your slope, and x1 is your x-intercept on the graph. We were given the slope of -3/4, and we need to find the reciprocal slope to find the perpendicular line slope. And this right here is the same as y equals mx plus b. And here's our given point over here, 6, -1. Our slope is -3/4. And what do we need to find the perpendicular line slope? The reciprocal slope, which is 4/3. So I'm going to use my point slope formula and I'm going to plug in my numbers. Y minus -1 equals 4/3 times x minus 6. And here we're going to have to use the distributive property. These numbers on the left are not in our problem, but I just wanted to show you an easy example of the distributive property. So y plus 1 equals 4/3 x minus 8. And anytime you cross these lines, you have to change the sign right here. So y equals 4/3 x minus 8 plus or minus 1, or y equals 4/3 x minus 9. And I like to check my work, so I'm going to show you how to do that real quick. Y equals 4/3 x minus 9. That was our answer that we figured up earlier. Then I'm going to take the x from our given point plot, and I'm going to plug it into x. So y equals 4/3 times 6 minus 9. Y equals -1. This -1 should look really familiar to you because it's over here in our given point plot. -1 is y. Now then, let's shoot over to Excel. And this is how my graph originally looked before I put it into PowerPoint. And I want to show you that this is a right angle by putting the triangle there. And to find the slope, we can just pick a point where it intersects at. And let me draw for you. We're going to use our point slope formula of y minus y1 equals m times x minus x1. And we're going to use the point 15, 15. And you can label them if you would like. Y minus 15 equals 4/3 times x minus 15. We're going to use the distributive property. 4/3x minus 20. Let me come down for some more room real quick. Then I need to solve for y. So I'm going to isolate y on the left-hand side. And anytime that I cross these lines, I have to change this sign. So it's going to be 4/3x minus 20 plus 15. And then our answer is y equals 4/3x minus 5. You can always check that like I showed you earlier. Sorry to be back and forth. I just wanted to show different things in PowerPoint and in Excel. Okay, we are given, I wanted to use some different values again, so I just used -6 to 6. And we were not given y equals 2/9x plus 3. But I'm going to show you how I got that in just a moment. But my x values had to follow this function. Let's do a little bit of backpedaling for just a moment. We were given 2y plus 9x minus 5 equals 0. So I need to solve for y. So I take 2y equals 0 minus 9x plus 5, and I divide both sides by 2. So y equals negative 9 over 2x plus 5 over 2. This gives me my slope of negative 9 over 2. But in order to solve the perpendicular slope, I need the reciprocal, which is 2 over 9. And then I'm going to use my point slope formula, which is y minus y1 equals m times x minus x1. And I'm going to use my given point plot, which is 0, 3. Y minus 3 equals 2 over 9 times x minus 0. Y minus 3 equals 2 over 9x. And y equals 2 over 9x minus 13. I'm sorry, that's a 3. I didn't think that was right. 2 over 9x plus 3. Sorry. And then I'm going to check my answer by plugging in the x-axis into my x variable. 2 over 9 times 0 plus 3. And y equals 3. And what is our y-axis? It's 3. And let me go back to Excel and show you how my graph really looks when it's in Excel and not distorted. And I'm going to put my square in there and show you that it is a right angle. And in PowerPoint, I gave you the slope already. And then question number 6 asks us to find a tangent line on the circle. And our tangent circle has a radius of 9, and it's at the plot point of 0, negative 9. Now, I want to take a minute and just give a small lesson in plot points and the axes. I probably should have done this earlier, but it just came to me. There are two axes, right? There's the x-axis right here, which goes from left to right, horizontal, and you have a y-axis that goes vertical, up and down, and they meet at a center point called an origin. And we said that our circle had an origin of 0, 0. Each axis both has a positive and negative values. We're given a plot point of 0, negative 9. 0 is on the x-axis, and negative 9 is on the y-axis. It goes in alphabetical order. X, Y, Z. 0 is X, and then what comes after X? Y. Negative 9 is Y. Hang on. I want to manipulate this a little bit, so I'm going to change my view. I want to put this here. This was given information. The X goes first, which is 0. And then negative 9, 0 goes here. And then 0, 9. And then 9. Oh, sorry. 0, 9 and 9, 0. Now I need to show a tangent line. What is a tangent line? A tangent line is a line that touches the bottom of a circle. Not inside the circle, it's on the bottom, touching it right here. And then I'm going to go to Excel and show you. I used a chart here to plot my points, negative 9, 0, 0, 9, 9, 0, and 0, negative 9. And then I placed my circle on my graph. Now I'm going to go back to PowerPoint. And here is the equation of a tangent line. Y minus D equals A minus C divided by D minus B times X minus C. I like to think of it as the X, Y variables because A, C, D, B could get a little confusing. So I changed it to Y minus Y1 equals X1 minus X2 divided by Y1 minus Y2 times X minus X1. And then I plugged in my values into my formula, and we get Y equals negative 1. I mean negative 9. Y equals negative 9. But what if our tangent circle is at 0, 9. Well, what if it was? Let's find out. Let's copy this, paste it. Let's move our tangent line to 0, 9. So what happens here? We have a tangent line in the negatives below the circle. We have a tangent line in the positives above the circle. We can also do this in PowerPoint. Here's my tangent line at 0, 9. We can see the difference in between them. And I want to thank you for listening to my presentation. And I hope that you have a great night. Thank you.